Okay, you should be on page 211. This is block 8 from topic 7, rational numbers. 211. So, number 1, Gina is a scuba diver. And she starts 10 feet below sea level, which is a negative 10. She begins to descend. What does descend mean?
Go
down further. At a speed of 15 feet per minute. It takes her 4 minutes and 20 seconds to get to the dive site at the ocean floor. So at 0 minutes, she's at negative 10. So at 1 minute, where would she be? If she's going, we're descending, going down 15 feet per minute. So she's going further down. That gets her at where?
Negative 25.
Negative 25. Then another minute passes, which means she went down another 15 feet, which means she's at negative 40. Then another minute passes, meaning she went down another 15 feet, and she's at a depth of negative 55. Then another minute passes, and another 15 feet, and she's at negative 70. But she said that it took her 4 minutes and 20 seconds to get to the dive site. This is only 4 minutes, and she's negative 70 feet below sea level. Has she made it to the dive site?
20 seconds left.
She has 20 seconds out of how many total seconds? 60 seconds are in a minute. So essentially, she is diving for a total of 4 1/3 minutes, right? So I need to know at what depth her dive site is. Well, it's going to be below negative 70, but is she going down another 15 feet? No, she's only going 1/3 of a minute further down. Anybody know a way to find that? Cole?
Well, I divided 20 by 60. I divided 60 by 20 and got 3. And then I divided 15 by 3 and got 5.
60 by 20 and got 3.
Yeah, and then I divided 15 by 3 and got 5.
Okay, so basically the same thing. 1/3 of 15 is really 15 divided by 3. Where is 15 coming from?
The
feet
per minute.
That's feet per minute. So do I need to go down a whole nother minute?
No.
Just 1/3 of a minute. So 15 divided by 3 is really 5. So how much further is she going down? 5. So where is the depth of her dive site? Negative 75. Very good. Okay, number 2 is really a homework question, but I'm going to walk through it. It says to write a number sentence to find Gina's depth after 4 minutes and 20 seconds. Well, what was her final depth?
Negative 75.
So I know it equals negative 75. Where did she start?
0.
Negative 10.
Negative 10. What was added to that? I know it was negative 10. Is she going up or down? What's going to tell me go down? A negative. How much further does she need to go down?
65.
65. So negative 65. A lot of times they put this in parentheses so you don't have two symbols sitting next to each other. Okay, let's take a look at number 3. it reads, Gina starts at a dive site at negative 75 feet. She ascends. What does ascend mean? Goes up because descend means go down. Davenport. So she ascends to the surface at a rate of 20 feet per minute. She stops for 2 minutes at negative 15 feet, then finishes ascending at a rate of 10 feet per minute. How long does it take her to return to the surface? That's a whole lot of something going on. I need diagrams. So I'm going to draw a diagram, and you're drawing it too. Okay? I know that she dove down how far? Negative 75 feet below sea level. Well, she's coming back up to the surface, and the surface is at sea level, which is 0 feet. Well, I thought that too, but like she was just already down by the time she started timing. She's like, oh, I forgot to start my stopwatch, and
Well, when you go off the boat, you have to get out.
yeah, that's true.
Technically. I found the answer. How she got a waterproof?
Can I teach or what? Okay. So she dove down 75 feet below sea level. She ascends. What does that mean? She goes up, and where is her stopping point? She stops where?
Negative 15.
At a negative 15 feet. How fast is she ascending here?
I'm in.
Pretty fast.
Okay, and what is pretty fast?
20 feet per minute.
20 feet per minute is how fast she's ascending. Then she stops at negative 15 feet. How long does she stop for?
2 minutes.
2 minutes. She takes I'd say take a breather, but I hope she's not taking a breather.
Well, I mean, you can't ascend too fast.
She might be drinking some water.
What if you're
She might-
underwater and you sneeze?
Bubbles are created.
So, she reaches the negative 15 feet, takes a rest for 2 minutes, and then what happens?
She goes up.
She goes up the rest of the way at what speed?
10 per minute.
10 feet per minute. All right. The question asks, how long does it take her to return? Well, I know this break is 2 minutes. Everything else they're needing me to figure out. I know this rate, this first large section of this bar here, is 20 feet a minute. Any idea of how I can find the total time of this section here? Yes, sir.
Only difference between where she stopped and at negative 75 and 15,
And what is that difference?
60.
So this section here is 60 feet. That first section of the bar. Okay, proceed.
And then you divide it by 20, which
60 divided by 20.
that'll give you 3 minutes.
So 3 minutes, because 60 divided by 20, 20 feet per minute is going to tell me how many minutes it took her to ascend this section here. Okay, now I need to see how much it takes her to ascend this section here. Well, what is the distance here? 15 feet.
Oh, I know that.
Okay, but this time her speed is 10 feet per minute. So I found 3 about doing 60 divided by 20. So what's 15 divided by 10? 1.5 minutes. But that's, I want, what is that really? A minute and 30 seconds. Okay, now I have a total amount of time that I can find it taking her. So 3 minutes plus 2, I'm at 5, plus 1, I'm at 6 minutes. And what? 30 seconds. It took her to ascend 75 feet.
So it's slower going up and down because gravity.
It is slower going up than down, not because of gravity. Why can you not go up scuba diving as quickly? Caleb, how are you going to, how are you, based on pressure and oxygen levels down below, if I go up too fast, the oxygen levels and pressure in my blood will give you muscle spasms to where you cannot move and you would essentially then die.
But isn't that the same when you go down too far? No, that's when.
Only
That's different.
if you go too far down, yes.
Isn't that when you go
One person that I call on at a time. That is the same thing when I'm in an airplane. The airplane takes care of the cabin pressure. They pressurize the inside of the plane so that it does not affect us too greatly. When your ears start to feel like they need to pop, that's because the pressure in your body's off a little bit. And the plane is trying to get the pressure right. If they were to bust a window or a door open, the pressure would change dramatically and you would need to get to the ground pretty quickly before effects start taking place in your body.
What about those movies where like the airplane let's say metaphorically like an Iron Man, like Iron Man 3 I think, when like the plane cut in half and they're all like in the plane itself.
That's only you're only allowed to jump off a plane at a certain height. That's not as high as a plane normally goes.
But they're like
I mean, it's still high.
It was some animals and they weren't even like floating. They wouldn't even move. Like they didn't have.
Yeah.
They used insulation.
Okay, moving to problem 4. The record for the deepest scuba dive was set by an Egyptian named Ahmed Gabar. He dove 1,090 feet below the surface of the Red Sea. It took Gabar about 12 minutes to reach the record depth. However, the trip back up to the surface took about 15 hours to ensure a safe return to the surface. Okay, so he was so far down, the pressure in his body was changed dramatically that if he did not take that slowly coming back up, he would kill himself. So it took him 15 hours to come back up. If I was that far down in the ocean, I'd probably panic and want to get up extremely fast and I'd kill myself. So that's why I don't scuba dive.
Wait a minute. How? Okay. How good of a oxygen tank does this man have?
Those tanks can last a pretty good while.
it's not an oxygen.
They don't last 15 hours.
All right, so first we're going to look at how fast it took them to get down versus how fast it took them to get up. So first we're looking at descending, which is going down, and we're looking at his rate. How many feet did he need to go?
1,090.
1,090. How many minutes did it take him? 12 minutes. I wanna look at that as a unit rate in 1 minute. So how do I change 12 to a 1?
1090 divided by 12.
Okay, divide it by 12. Let's round to the nearest whole number. So about how many feet per minute?
91.
Wait, Miss Adams.
You get 190.
It's like
60.
91.
91 feet per minute. Okay, that's how fast he descended. Now let's look at how fast he ascended, went up. So how many feet does he need to go up?
1,000.
Same distance, I hope. How many hours did it take him? 15. We want to look at the unit rate per hour. So what do I need to do here?
1090 divided by 15.
Divided by 15.
We did.
73.
That's 73 feet per hour. But can I compare these two unit rates, a per minute and a per hour?
Yes.
I need them in the same units. So let's change this to minutes. How many minutes is in an hour? 60 minutes. So I'm going to do 73 divided by 60. We'll round to the nearest tenth place. That's 1 decimal. So his ascending rate was 1.2 feet per minute. So let's recap. Descending, 91 feet per minute. He went up 1.2 feet per minute. Look down at these squares on the floor. That's 1 and a little bit more of a square per minute. That's like slow. And that's what he had to do in order to come up safely. I don't know about y'all, but I don't know I have enough patience for that. I'd be swimming and it'd be like, oh, I'm dying.
They're like all the way down there, but it only takes them like 1 second to get back up.
I would get on
Hey, Miss Adams.
Hush. Let's move to number 5. Number 5 is just an order of operations problem, refreshing our memory. It looks pretty crazy, but we just take it step by step. What is the first order of operations we need to handle? Parentheses. Is there work in my parentheses?
Yes.
Okay. What operation is being done in my parentheses? Okay. I'm going to rewrite this. Do I divide fractions though?
No.
What do we do with dividing fractions?
Multiply by the reciprocal.
Multiply by the reciprocal. Thank you, Aiden. That was great.
That wasn't him.
I know. So I rewrote my problem. It already looks nicer. Okay. I can multiply these fractions now and get 3/6. Can 3/6 simplify?
Yes.
So 1/2. Okay. Any other work with I still have a parenthesis there. Is there work inside my parenthesis I need to do?
No.
Inside my parenthesis?
No, because
Okay, so what do I need to handle next? Exponents. So is this 1/2 times 2?
No, it's 1/2.
Okay, I'm rewriting it. Notice how much work I'm rewriting, ensuring that I get the correct answer. Difference between A plus work and F work. Okay. 1/2 times 1/2 gives me 1/4. Now I have What operation comes next? Multiplication and division in order that it comes. So I see a multiplication, whole number times a fraction. I pretend this whole number is over 1. So that gives me -2 over 4. Can this simplify?
No, baby.
That simplifies to -1/2. I'd probably look at my number line for this just to make sure I'm on track. This says you're starting at -1/2, which is there. And I'm going up or down? Up 5. Up 1, I'm at 1/2. 2, 3, 4, 5.
4.5.
So here, this should be a positive or a negative?
Positive.
Positive 4.5.
And that's what probably doing. You either simplify it to a decimal.
Wait, this out since it's a negative 1/2, could you just do 5 minus 1/2?
Does order matter in addition problems? No. But if it was a subtraction?
Yes.
Okay, I want you to work number 6. The answer to number 6 is -38. When you have work proving your -38, raise your hand. I'll check it, and then you will be released to do online work. Thanks for listening. Have a great day. Like, subscribe, hit the notification bell, and peace out, home dogs.